By definition, it's just a specialized type of chuck. It's like a round disc of material. And that disc or chuck utilizes electrostatic force to hold things in place. So electrostatic chucks are used in semiconductor, and that's why we're here talking about it today. They hold the wafers in place while etch and deposition processes are taking place at the surface of the wafer. Lots and lots of chips that will come off of each individual wafer. You can see them patterned there on the bottom right-hand side. And the fact that this wafer, during a lot of very critical stages of its processing, will be sitting on electrostatic chucks. So, where would an electrostatic chuck be found in actual semiconductor, in a fab, or semiconductor equipment? So what you see here is a top-down view of a typical cluster tool in semiconductor manufacturing. You see 4 different process chambers that are labeled 1 through 4. That's where a wafer is being processed in either etch or deposition, or in a variety of other processes that we won't care to mention in this particular presentation. So basically, you have wafers that are being funneled in and out of these process chambers to have process done on the surface of each wafer. So this is how it actually works. And by the way, every time you see the acronym ESC, it refers to electrostatic chuck. So what you see on the right-hand side is a 300 millimeter electrostatic chuck, top and bottom view. The top is made out of some type of ceramic, generally speaking, alumina, something like this. And the bottom is usually anodized base plate, anodized aluminum. See 3 little holes going through the electrostatic chuck as well. Those holes allow for lift pins to come up through the chuck. That's how the wafer is actually transferred onto the electrostatic chuck. It gets dropped off on these lift pins, which then lower, right? You can see it on the pins here, the wafer's on the pins, and then the pins lower, and the wafer is now sitting on the electrostatic chuck. Now that the wafer is in the chamber, we need to take a closer look inside of the chamber to see exactly what is happening. So you can see the electrostatic chuck is sitting here inside of the chamber. A wafer is now sitting on top of it. Here's where things start to get interesting. When you're etching or depositing things on this surface of this wafer, a lot of times this phenomenon known as plasma is happening, right, as part of the process. So that plasma is actually what leads to electrostatic chuck failures. So now we know where the electrostatic chuck is in a process chamber, in the semiconductor world, in a fab, with a wafer which could be worth tens of thousands of dollars in chips sitting on top of it. Very critical application.